Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Today we're going to be discussing key features of graphs, and the first thing that we're going to look at is y a function of x. We get this question a lot in Algebra 2 classes and also in college algebra classes. A lot of times in Algebra 2 classes, our books just say, is it a function? So to look at that, we're going to look at something called a vertical line test. And we'll be abbreviating that the VLT. So what is a vertical line test? If you were to draw a vertical line, it can cross your graph at most one time. Okay, so it doesn't have to cross at all, but it can't cross more than one time. In books, you're going to hear a comparison to your input and your output. I find the visual is much faster for a lot of students. And if nothing else, if you need to, you can graph it using a program called Desmos, and Desmos will help you see whether or not it's a function. So let's look at one shape drawn in two different ways. I'll slide this up in just a sec. There we go. And I'm going to use an absolute value equation, but one time it's going to be a function and one time it's not going to be a function. And that's based off the input and the output. Don't have to worry about that right now. We're just worrying about, is y a function of x? So in general, for my Algebra 2 level classes, I'm just going to ask, is this a function? So if I were to draw a vertical line here, and it touches once, it touches once, it would cross once, it would cross once, it would cross once. No matter how far I go out, a vertical line that I drew would touch at most one time. Therefore, this is a function because it passes the vertical line test. Over here on the right, if I were to draw in this vertical line, it meets this particular graph at two locations. Because this is more than one time, this fails the vertical line test, so it is not a function. It doesn't mean there's not a relationship, it's just not a function, as in y is being a function of x. We have many graphs out there based off of various relationships. They're just not all functions. So all graphs exist that we want to draw, just not all graphs that we draw are functions. Moving on, one of the things that we're really going to need to focus on with your mathematical knowledge is notation. And with your notation, that's just the way we express our answers. We used to, when you were probably in grade school, write things like x is greater than 5. And this is a simplistic version of notation. It's actually, when you get to college algebra, you're going to be expected to take this and make this a little more fancy, and it's going to be called set notation. So we're still going to include this part where x is greater than 5. But the important part of this is going to be in the extra information that's put in here. Oh, that was not the best brace. So x is greater than 5 shows up in both spots. When we see the braces, it means the set of. Sometimes they'll just give us a list of numbers. In this case, they're giving us an inequality because we have a symbol that's not an equal sign. So what this means, the set of all x's, because the variable is x, and then we have that line. That line is a way of saying such that. So this reads, the set of all the numbers x such that x is greater than 5. So old school notation versus proper set notation. Just a slight adjustment. I know a lot of people think that this happens to be just a waste of, ink or lead, and I get that. It's just the very, very formal way of representing it. You also probably in grade school had to put these on a number line. When I do my number lines, I don't always start at 0. Since this is a 5, I'm going to put 5 in the middle. And 5's between 4 and 6. Now, I tell my students that this is like a turn signal, like a blinker. Anytime you see turn signals, we'll have shading. So if you remember, in elementary, we would have put an open circle in the 5 because it's not underlined. And we're going to shade to the right or towards the 6 because 6 is greater than 5. So we'll have our shading that direction. And it will continue on and on forever. This is an example of number line notation. Which, it's easy to see because we use a number line. We're going to elevate our number line slightly. Instead of doing an open circle and an arrow, we're going to use a parenthesis and the arrow. So we're just changing out that open circle to a parenthesis. Now, if it went the other way, we would have used the other parenthesis. And that just means we can get very close to it, but not touch it. So we can get almost to 5, hence 5.01 is okay, but 5 itself is not. So we are going to look at the set of all x's such that 3 is less than or equal to x, which is less than 9. So again, the set of all numbers, x, such that 3 is smaller than or equal to x, which is smaller than 9. Now in this case, when we do our number line, I'm just going to go 0, 5, 10. Since this is underlined, we would have used a closed dot on the 3 because 3 can be included. Sorry, that was a little off. I should have put it closer to the 5. And then we would have used an open circle on the 9 to show that it was not included. 8.999 repeating is the best we can do. And we would have connected them. Now, when we're switching to parentheses, the 9 is going to be a parenthesis, and you'll notice that, I need to slide that up. You'll notice that I use the ending parenthesis instead of the beginning parenthesis because that was the end of our graph. And we're going to come back here. So what are we going to use instead of a solid circle? Instead of a solid circle, we're going to use a bracket. Depending on whether it's the beginning or the end, you will use the appropriate bracket. So it would look like that. So why would I use bracket and parenthesis instead of open circle and closed circle? Well, one thing that's nice is there are actually buttons on the keyboard, so we can easily type them in. But the whole idea between the parenthesis and bracket is leading us into something that we will use the most, and that is going to be interval notation. Interval notation is by far my favorite. One, because I do math classes and it's easy to type in. So x, because we need to define our variable. And then we have this funny little, it's kind of like a C with a line through it, and that means is an element of. And then it's going to give me an interval between this and this. That's what an interval is, from here to there. So our last example, we had it between 3 and 9. So if we notice, the bracket and the parenthesis from our number line became our bracket and our parenthesis for our interval. So this just states the interval from 3 to 9, including 3, not including 9. So 3 is guaranteed it's going to work, but we're going to get close to 9, just not quite reach it. So let's look at that previous example where we were looking at x is greater than 5. If you recall on the number line, it was a parenthesis starting at 5 and it continued on. And technically it continues on to infinity. So in our interval, that's going to be starting at 5 but not including it and continuing on to infinity. So let's go ahead and let's look at one example from all the notations together. Let's go with x is less than 9. So we need to look at our proper set notation. We need to look at number line notation. And we need to look at interval notation. Again, with that set, it's really just using the braces, our variable, and that such that line, then rewriting our statement. When it comes to a number line, it's just that visual image. This time we're starting at 9 and going smaller. Again, there was a turn signal, so I had shading. This time I shaded to the left. And then with interval, our variable was x. If you use a different letter, you would just use a different letter here with that funny symbol, meaning an element of. And this time it starts at negative infinity and it ends at 9. And since we can never hit infinity, infinities will always have a parenthesis on them, so that's not a really big deal. Occasionally you will come across times where the answer is no solution. We can't answer that one in interval notation because there isn't an interval that exists. So we can do it in set notation. In set notation, it would just be an empty set. We wouldn't write anything in it. That's technically no solution. Some books will just do a circle with a slash through it. So please make sure you don't write your zeros that way because that means no solution. Another answer that some people get is all real solutions. Okay, if we're doing the set notation, we would have to say all x's such that x is a real number. But that's a lot of writing to do, which is why I love interval notation. Because with interval notation, we're just going to say x is between negative infinity and positive infinity. Parentheses on both because, again, we cannot hit infinity. When you're in science class, you're going to normally see graphs like this with just the first quadrant, while in math class we use all 4 quadrants. And therefore, we're going to talk a lot in math class about our domain and range. In other classes like science, you're not going to call it domain and range. You're going to call it your independent variable or your dependent variable. And I use the word variable, so the independent variable is your x and the dependent variable is your y. Maybe in junior high class you might have called it your input and your output. All these words are going to be great ways of describing your different parts of your equation. We're going to use them to discuss different key aspects of a couple different images. For those of you who like to take notes on videos as you go for your personal use, I have drawn the same image 3 times, and we're going to do this so that we can look at some different key characteristics depending on what your ideal information is. So in this case, we're going to notice that this comes down to a point, and this happens to be the lowest point on the graph. So if you're asked whether it's a minimum or a maximum, we notice that we have a minimum. How low does it go? Well, it goes down 1 below. So the lowest point is a value of -1. And that happens to be at our vertex, which is the ordered pair 2, -1. The other thing that we can clearly see here is sometimes they'll ask you for the zeros or the roots. Okay, zeros or roots. These are actually just your x-intercepts. If they ask it in the term 0 or roots, we're just going to list the x value. So it's the set of all numbers, 1 and 3. And of course these are x's, so x is, we can write that like, so this is a list. If they ask you for the x-intercepts, it's better to write them as ordered pairs, 1, 0 and 3, 0. So depending on how the question words it, I'm either going to say, hey, it crosses at 1 and 3, or I'm going to write my x-intercepts of 1, 0 and 3, 0. The other thing I want to look at is the domain and range of this, and I'm going to write this up above the picture. Okay? So domain is like your walls, okay? But because this continues all the way to the left and all the way to the right, there are no walls. So since there are no walls, okay, our domain, or our x's, are between -infinity and infinity. And that's because the graph keeps going to the left and it keeps going to the right. This would be what our domain is. Our range is going to be like our ceiling and our floor. Okay, so we bottom out or have a floor of -1, but it continues up from here. So there's no ceiling. So now I'm going to use a y, because we're talking about the y's, is between -1 and infinity. And because there's a dot at -1, we're going to go ahead and use that bracket. Okay, so now I'm going to highlight some other key features. Highlight that in pink. And I'm going to use some purple to highlight this part here. So how does the pink differ from the purple? You might notice that the pink is declining left to right, or decreasing, and the purple is increasing from left to right. So on this side of the image, we are decreasing. And on this side, we are increasing. So now we need to use the walls, quote unquote, the walls, to discuss it, because x is our independent variable, so we always describe graphs based off of x. So where is the graph decreasing? Well, that's going to be when x is between -infinity and 2. I need to write better tonight. Okay, so between -infinity and 2. Now, at 2, we're neither decreasing or increasing. We're making a switch, so I can't include 2 this time. So I'm going to use a parenthesis on 2, and of course -infinity is always done. Increasing is going to be when x is between the wall of 2, and then of course on the right there's no wall, so that would be infinity. So 2 and infinity. So that's the difference between increasing and decreasing. It is really uphill and downhill. So same image, now we're going to look at another part, so let's highlight this a little bit differently. Still going to use purple and pink. Okay, so there wasn't very much of this that was highlighted in pink. But where it is pink, you'll notice that the pink is below the x-axis. And in the purple, we are above the x-axis. It's because this is the line y equals 0. So we're going to talk about when is a graph greater than 0 versus or above 0 versus below. And of course, we're going to describe this based off of our x's. So one thing we're going to look at is when is it's positive, meaning above 0, which really means above the x-axis. And we notice that we have two sections of that. Okay, the x-intercepts really show us that because the x-intercepts are where it equals 0. So we're going to be looking at our walls, and this section is between negative infinity and 1. But we can't include 1 because strictly above or positive. And then it starts over again at 3. And again, there's no wall on the right. Anytime you have two groups, we're going to join them with the symbol called U for union. And that's based off our x. So if we choose any x's in one of those intervals, our y value is going to be above 0. For the below, our graph extends below the x-axis between these two walls, between 1 and 3. So if they ask you when it's negative or below the x-axis. So that's very different from when we are looking at increasing, decreasing versus positive, negative. So make sure you understand the difference between your vocab words because those are going to be very key. The vertex was what switched our decreasing to increasing. The zeros are what switched us from positive to negative. When discussing key features of graphs, another thing that you might hear them refer to is the average rate of change. And then you might see them write f of b minus f of a over b minus a. This is just another way of saying slope. y2 minus y1 over x2 minus x1. So don't let the notation fool you or worry you. It's just really talking about your slope, uphill, downhill, positive, negative kind of thing. So average rate of change is just really slope. You're good to go if you understand that connection. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.